So we are going to do conditional probability today. So the probability that one event happens, given that another event is already known to have happened, is called a conditional probability. If we know that event A has happened, the probability that event B happens, given that event A has happened, is denoted by this. So here's the notation. So we have the probability that B occurs, given the fact, straight line, that A happens. So this is the formula for finding it. The probability that A occurs given the fact that B happens is going to be the intersection of A and B divided by the probability of B. Or if you reverse those, it's still the intersection, the probability of B intersection A divided by the probability of A. So it is intersection over condition. So here's the two-way table showing education level and homeowner status. If we know that a person owns a home, what is the probability that the person is a high school graduate? So writing that out, we want the probability. They are a high school grad, given the fact, given they own a home. Okay. So if they own a home, we are looking at this row right here, because they must be homeowners. So what is the intersection of homeowner and high school graduate? 221. Divided by the total number of homeowners, which is 340. Okay, so put that into your calculator. And you should get like 0.65. Okay, well, the second one says, if we know that a person is a high school graduate, what is the probability that the person owns a home? Okay, so this one, we're flipping those around, right? We want the probability that they are a home owner, given the fact they are a high school grad. Okay, and so now, instead of looking at the row, they must be a high school graduate. So we're looking at this column. However, the intersection didn't change. It's still going to be 221. That's the intersection of homeowner and high school grad. But this time we're dividing by the total number of high school graduates, which is 310. Okay, and so that probability is like roughly the 71%, something like that. 0.71. Okay, so yes.
You still first two round them from now on?
They're not that big. Like in calculus, we always round to 3 decimal places, and that's important in stats. It's not that big of a deal, so that's fine. All right, and a question like this would probably be multiple choice, right? So you would have the answer there, all right? So let's look at this question. It's phone usage. Going back to those nodes. So we had cell phones and landlines, and we had the two-way table. This says, what is the probability that a randomly selected household with a landline also has a cell phone? So writing that out, we want the probability that they have a cell phone, given the fact that they own a landline. And for the sake of the notes, I'm going to go ahead and write this out. You don't necessarily have to do that on these problems, but following that formula, what's the formula again? It's the intersection of A and B over the condition. So I want the probability of cell phone and landline divided by the probability of landline. And so we are going to look at the intersection, which is right there. The percentage that have a landline and a cell phone is 0.51. Divided by the probability of the landline. And so we're looking at the total that have a landline, which is right there. So we're going to have 0.51 divided by 0.6, which is approximately, what's that, like 0.85, something like that. Okay. Questions for me so far? Conditional probability is always intersection over condition, okay? And I believe that that is also on your formula chart there. So let's take a look at another example. Okay, and so it says, students at the University of New Harmony received 10,000 course grades last semester. The two-way table below breaks down these grades and by which school of the university taught the course. The schools are liberal arts, engineering and physical sciences, and health and human services. Okay, college grades tend to be lower in engineering and the physical sciences than in liberal arts and social sciences. Choose a University of New Harmony course grade at random. It says consider these two events. We're going to let event E be the grade comes from an engineering and physical science course. And we're going to let event L be the grade is lower than a B. So this says find the probability of L and interpret this probability in context. Okay, so event L is defined, the grade is lower than a B. So how many total grades lower than a B are there? It would be that number right there. So we've got 3,656 divided by the total number of grades, which is 10,000. We don't even need a calculator. Or we shouldn't, right? What percentage is that? 0.3656. But then it says, interpret this probability in context. Okay, so we're going to say there is a 0.3656 probability of getting or I'm going to say there's a 0.3656 probability of selecting a course grade lower than a B. So the next part says, find the probability of E given L and the probability of L given E. Which of these conditional probabilities tells you whether this college's EPS students tend to earn lower grades than students in liberal arts and social sciences? Okay, so let's do that. We want the probability of E given L. That is going to be the probability that they are in the EPS school, given the fact that they have a grade lower than the B. So we're gonna find the intersection. And intersection engineering and physical sciences lower than a B is that number right there, which is 800. So we've got 800 divided by the condition. And the condition, what's the total number of grades lower than a B? 3,656. Which is 0.219. And now we're gonna find probability of L given E. Which is going to have the same intersection, which is 800. But this time they must be in the engineering and physical sciences school. And the total in the school is 1,600, which is 0.5. And so now I'm going to answer the second part of the question. So the probability of L given E gives the probability of getting a lower grade. Given that the student is studying in the engineering and physical sciences school. Okay, so I want you to think about this for a second. What's the probability, the overall probability that they get a grade lower than a B? We found that in the first part, right? It was roughly almost 37%. Okay, well, if they're in the engineering and physical sciences school, what's the probability that they get a grade lower than a B? It's 0.5. So since that's greater than the overall probability, then that means that there's a larger chance of getting a B in those classes, meaning that there are more, excuse me, I said that wrong. Look, there's a larger probability of getting a grade lower than a B in that school than in the overall, which means there are lower grades in that school, since the probability is larger. So I'm going to say because this probability of 0.5 is greater than the probability of L, which was 0.3656. We can conclude grades are lower in the EPS school. So again, the overall probability of getting a grade lower than a B is like 37%. However, if you're in the EPS school, the probability that you get a grade lower than a B is exactly 50%, meaning that there are more grades lower than a B in that school than overall. And that leads us to this. It's called the general multiplication rule and tree diagrams, which we're going to look at in just a second. So that says the probability of A and B is the probability of A intersection B, which is the probability of A times the probability of B, given the fact that A has already occurred. Okay, so let me explain that. Okay, with an example. Playing in the NCAA. About 55% of high school students participate in a school athletic team at some level, and about 5% of these athletes go on to play on a college team in the NCAA, according to that study. So this says, what percent of high school students play a sport in high school and go on to play a sport in the NCAA? So let's write down a few things. The probability that they play high school sports. That probability is right there, 55%. So this is 0.55. And then what is the probability that they play a sport in college, NCAA sport, given the fact that they played a high school sport? Well, that is this number right here. It says 5% of these athletes go on to play on a college team in the NCAA. So this is 0.05. Okay, so back to the formula. The general multiplication rule says the intersection of those two things is going to be the probability of the first thing times the probability of the second thing, B, given the fact that the first thing has already happened. Okay, so writing this out. So the probability that they play a high school sport and an NCAA sport is going to be the probability of the first event, probability of high school sport, times the probability that they play an NCAA sport, given the fact that they played a high school sport. And so this probability is 0.55. And the second probability is 0.05. And so put that into your calculator. The probability that they played a high school sport and then an NCAA sport is, someone help me out with that, multiplying those two things, it is 0.0275. Okay, so the probability that you played in high school and then at NCAA is a little less than 3%. Just for fun, let's take it one step further. Let's say we want to know the probability that you become a professional athlete. So what percentage of college sport athletes go on to play professionally for, let's say, 3 years? No, I don't know, like 47% of all stats are made up on the spot. That's a little funny, right? I mean, give me a little bit of credit. I know it's early, right? But I'm gonna say, let's say 3%. let's be generous, let's say 5% of college athletes go on to play professionally. It's probably not that high, but let's just go with 5%. So how would we calculate probability that they played high school, then they played college, then they became a professional? It would be 0.0275 times 0.05. And what is that? Owen, your all-time calculator person today, what is that?
0.001375.
Pretty low, right? So here's Newhouse's advice, right? Follow your dreams. Go for it. But have a plan B. 'Cause I'm gonna tell you, probably not gonna work out. There are a lot of things that could go wrong. That said, follow your dreams. Okay? But the probability that you're going to make a living as a professional athlete is pretty low. Okay, if we are being realistic. All right, so the general multiplication rule is especially useful when a chance process involves a sequence of outcomes. In such cases, we can use a tree diagram to display the sample space. All right, so here we go. Don't lie, or I will know. As all-knowing supreme stats dictator, raise your hand if you hit the snooze button this morning more than once. So Shannon hits the snooze bar on her alarm clock on 60% of school days. If she does not hit the snooze bar, there is a 90% probability that she makes it to class on time. However, if she hits the snooze bar, there's only a 70% probability that she makes it to class on time. On a randomly chosen day, what is the probability that Shannon is late to her stats class and gets a detention and has made a bad choice and spends Friday here at school when she should be out doing bigger and perhaps even better things? So let's find that probability. So there are two outcomes to start with. Either she hits the snooze or does not hit the snooze. So what is the probability that she hits the snooze? 0.6. And using the complement rule, the probability that she does not hit the snooze is therefore 0.4. Okay, so now this is the tree diagram. There's two possibilities if she hits the snooze. She is on time or she is late. And the same thing if she does not hit the snooze. She can be on time or late. And so let's go back and write down those probabilities. It says if she does not hit the snooze, there is a 90% probability that she makes it to class on time. So does not hit the snooze, makes it to class on time. This right here is 0.9. Meaning that this has to be 0.1. Complement. And if she hits the snooze bar, there's only a 70% probability that she makes it to class on time. So this is 0.7. And so this would be 0.3. Okay, and so the general multiplication rule, along with the tree diagrams, says What is the probability that she is on time, given the fact that she hits the snooze bar? Well, we're going to multiply those two probabilities together. So 0.6 times 0.7 gives us 0.42. And the same thing here. What is the probability that she is late, given the fact that she hit the snooze? 0.6 times 0.3, which is 0.18. What's the probability that she's on time, given the fact that she does not hit the snooze? 0.9 times 0.4, which is 0.36. And this one would be 0.1 times 0.4, which is 0.04. So what do I get if I add these probabilities? It has to be 1. Why does it have to be 1? How many possibilities are there? There's 4. What's the sum of all the different possibilities in a sample space? Has to be 1. Okay. My next question. Are these events mutually exclusive? These events are mutually exclusive. Because is it possible to be late and hit the snooze and late and not hit the snooze? No, those two things are mutually exclusive. So I'm going to go back and answer the question. What is the probability that Shannon is late for class? Well, if the events are mutually exclusive, then I'm going to use the addition rule, and I'm going to add the two events where she is late. So she was late here, which is 0.18. She was late right here, which is 0.04. So the overall probability that she is late, so probability okay, well, let's look at all right, we're back. So since these two events are mutually exclusive, if I want to calculate the overall probability that she is late, I'm going to use the addition rule and add 0.18 and 0.04 to get 0.22. And then the next question says, suppose that Shannon is late for school. What is the probability that she hit the snooze bar that morning? So I want to find the probability that she hit the snooze, given the fact that she is late. And so let's write it out. How do we find, this is a conditional probability. How do I find the conditional probability? It is intersection over condition. So I want the probability that she hits the snooze and is late over the probability that she is late. So what is the intersection? What's the probability that she hits the snooze and is late? We found that previously it is 0.18. And we're going to divide that by the overall probability that she is late, which is 0.22. So 0.18 divided by 0.22 is like 0.818, something like that. All right, we're gonna do like one more example and then stop so that you can ponder your little quizzes that you took yesterday. Okay. So. Let's try and do one more. Okay. The Kaiser Family Foundation recently released a study about the influence of media in the lives of young people. In the study, 17% of the youth were classified as light media users. 62% were classified as moderate media users. And 21% were classified as heavy media users. Of the light users who responded, 74% described their grades as good, A's and B's, while only 60% of the moderate and 52% of the heavy users described their grades as good. Suppose that we selected one person at random. Part A says, draw a tree diagram to represent this situation. So we got students. And there are three different possibilities. You are a light user. You are a moderate user. Or the very first step is admitting that you have a problem. You are a heavy media user. You suffer from separation anxiety. When you put your phone in the box, it's like you're on the dark side of the moon, cut off from all communications of the world. So, what are these probabilities? Light user is 0.17. Moderate, 0.62. And heavy, 0.21. Okay, so we have two different possibilities for each one of these. We have good grades. And we have bad grades. And then for the moderate users, we also have grades. Bad grades. And for the heavy users, we have buenas calificaciones. Oh. Spanish lesson is over now. Let's carry on. The things that you get in stats class. Okay, so let's write down these percentages. Okay, how many light users classified themselves as having good grades? It was 74%, so 0.74. So this one would be 0.26. Moderates were 0.68. So the bad grades would be 0.32 for that. And then the good grades, 0.52. And so this would be 0.48. So this is my tree diagram. And let's do the last question here and then we'll call it a day. Okay. So part B says, find the probability that this person describes his or her grades as good. Okay. So we're gonna do the probability that they get good grades. Well, these events are mutually exclusive. So we're going to add them, but first we've got to do the general multiplication principle. We've got to multiply those probabilities together. So we're going to do 0.17 times 0.74. And then 0.62 times 0.68. And then 0.21 times 0.52. All right, so that's going to give me 0.17 times 0.74 plus 0.62 times 0.68 and 0.21 times 0.52. And so I'm going to write down these probabilities for the separate ones. This was like 0.1258. And then 0.4216 and plus 0.1092. And again, since these outcomes are mutually exclusive, we are going to add these together. And so the overall probability that they get good grades is 0.6566. Seems a little high to me, but
Why are you multiplying, the?
okay, because what is the probability that they get good grades given the fact that they are a light user? Okay, it's a conditional probability and we follow the general multiplication rule. And so we've got to multiply 0.17 times 0.74. And then we do that for each one. And so then the overall probability that they get good grades, since those outcomes are mutually exclusive, we add those three things together. That makes sense? And so let's do the last question here. It says, given that this person described his or her grades as good, what is the probability that he or she is a heavy user of media? So we want the probability they are a heavy user, given the fact that they get good grades. Conditional probability. Probability. Heavy user. And good grades. Okay, so we have the intersection over the probability that they get good grades. All right, and so what is the intersection? Heavy user and good grades is this right here, which we found. So 0.1092. That's the probability that they're a heavy user and they get good grades. Divided by the overall probability that they get good grades, which is 0.6566. And so the answer to this one is 0.1092 divided by 0.6566, which is 0.166.